Hello, everyone. I'm Steve Johnson. This is Digital Works TV, and we have a special guest today, Joseph Pelfrey, the director of Marshall Space Flight Center since 2022. And I want to read just a teeny bit of your bio stuff. You worked in science and missions. You've worked on the Ares 1 upper stage. You worked on SLS as a whole, and about 10 other things that you've done during your tenure at Marshall Space Flight Center. And maybe that's why you're the director, because you've worked on just about every project and you kind of know your way around.
It's thanks for having me, Steve. It's good to be here with you. A tremendous career that I never could have mapped out as a small town kid from South Carolina.
Wait a minute, I have to interject. He's an Auburn graduate. Okay,
that's
go
right.
ahead.
That's right. That's right. It's Auburn's what brought me to the state of Alabama and helped me find my way here to Huntsville. But really. Tremendous opportunities to work on a lot of different programs. At Marshall, started on the International Space Station program and had the chance to help design and develop and integrate science experiments. Flew 30 different science experiments to the International Space Station, and then moved over to work rocket programs and technology programs, and just a career that I never could have imagined, for sure.
Yeah, and your career kind of points up that when people think of Marshall Space Flight Center, the older folk think of the Saturn V and the Space Shuttle and now SLS. But there's a heck of a lot going on at Marshall Space Flight Center that not necessarily connected with putting humans in space. Well, I mean, I guess it's all connected to that, but you know what I mean.
Yeah.
Rockets.
Absolutely, and that's that is a defining in my career, a non-traditional path compared to a lot of previous directors, because I did spend so much time working in some of the other areas in addition to working on rockets and large spacecraft. But we have a very robust science portfolio at the center, where we work in all 5 of the science disciplines that NASA participates in. When you think about earth science and heliophysics, the study of the sun, planetary science, astrophysics, and biological and physical sciences. One of the few centers that actually works in all of those. And we have some world-class scientists as part of our team and world-class facilities that are really vital to what the agency's doing in terms of exploration and scientific discovery. And we have a couple of Bruno Rossi Prize winners, which for those that not familiar, I call it the Grammys of astrophysics. It is a world-renowned award for astrophysics, and we have 2 of those scientists that are part of our team. And so just a part of our portfolio that most people aren't familiar with that we have at the center. A lot of work on with the National Weather Service that we provide in analyzing data from all the various NASA satellites that we use, and being able to process that data for decision makers on things like hurricane tracking that you see on the Weather Channel or other weather sources. It comes from NASA and Marshall teams that are processing that data. So that's an example of things that are not as well known that we have at the center. Okay, well
let's go to the SLS, and then we're going to go back to the moon. But let's go to the SLS. Where are we now? I mean, I know Ares 2 has, am I correct? It's been assembled or stacked.
So the Artemis.
Not Ares 2, Artemis.
Yes, excuse me. No, it's good. Artemis 1 was a tremendous flight in November 22, uncrewed test flight. The vehicle performed nearly flawlessly, and it gave us the confidence to be ready to go fly Artemis 2, which is our first crewed flight of SLS and Orion spacecraft to send 4 crew around the moon on a shakeout cruise of the systems and then bring them home safely in a splashdown in the Pacific. And so the Artemis 2 Space Launch System vehicle has been assembled and stacked at the Kennedy Space Center with components that came from all over the country. The larger components built down at our rocket factory at the Michoud Assembly Facility, which is outside of New Orleans. That is a part of Marshall Space Flight Center's footprint. And just this past weekend, we actually powered up the vehicle for the first time down at the Cape, started checking out all the systems, all the connections for the different components that came together, and continuing that process to prepare for that Artemis II launch, which is right now on schedule for April of 26, with a goal to actually pull it back to the left a little bit, maybe as early as February 26 if things keep going well.
And I guess we both know that could change in an hour. I mean, just the way spaceflight is. It appears, just from what I hear, that Artemis II is going to happen and Artemis 3 in some fashion is going to happen. Does SLS have a career after that, or are we straying into policy at this point? I don't want to do that, but I mean, everybody wonders, is SLS going to fly more than just 2 more times?
So the current direction from the administration that was released a few weeks ago as part of its budget proposal to Congress identified flights for Artemis 2 and 3 for SLS, and then a refocus to a commercial approach that details are still being developed for. And so there's still some open questions in terms of how we move forward after Artemis 3. What we do know is that their administration has an increased focus on continuing with lunar exploration, but also with Mars exploration.
Okay, am I correct? I mean, everybody's always said, why didn't we build some more Saturns? Could say we decide, you know what, for various reasons, we need to do an Artemis 4. Could another SLS be built without a lot of trouble, or is that something we'd have to think about right now, which would change things, obviously?
Right. And so at the factory right now, based on the current plans and direction, we have hardware in different forms of manufacturing out through Artemis 5. And so we have different components at different suppliers around the country. And so it really would depend on the direction from the administration on what they would ask. But it definitely could be done.
Okay. Changes, at least in the focus, off of lunar exploration and going to Mars. But there's still plans to put humans, Artemis 3, to put humans on the moon. Do we know the architecture of that? I mean, how it's going to be done? Because I know that it feels like, and maybe I just am thinking this, that we've had some different ideas about that, and they've changed again. Am I right about that, or is it still putting a gateway, kind of a small space station around the moon to do it that way?
So for the Artemis 3 mission, from the very beginning of the Artemis program, the plan is still the same. To have SLS launch the Orion spacecraft and the crew, to rendezvous with a SpaceX Starship, which is our first provider for a human landing system. They would rendezvous in low lunar orbit, and then 2 crew would enter the Starship and descend down to the surface for a 6 to 10 day mission, and then 2 crew would stay in the Orion spacecraft orbiting the moon.
Okay.
And then after the end of that surface state, those 2 crew would launch back off the surface in the Starship, rendezvous back with Orion, and get back in the Orion capsule, and then come home in the Orion capsule. So that's generally been the architecture from very early in the program, and that remains the case in the current planning for Artemis 3. And so returning humans to the surface of the moon for the first time in over 50 years is still a pretty exciting milestone to have for Artemis 3.
What's the tentative date on that?
Mid-2027 right now is the current planning. Obviously, subject to schedule and development of all the major components. It will bring together not only Orion and SLS, but also the new Starship from SpaceX, which is our first partner on the Human Landing System program. We manage our program at Marshall. We also have a second provider for later flights with Blue Origin. And so our teams are working with both of those companies on a daily basis to develop those human landing systems that are going to return humans to the moon and provide that opportunity for a cadence of flights to the surface of the moon.
Okay, real quick interjection. Can you hear and those are Blue Origin engines I hear tested in the evening. Can you hear those from your house?
I can. They rattle my windows pretty well. It's a great sound. Most of the time, those are Blue Origin tests. Sometimes there are tests. We are also testing different engines and thrust chambers and different components that make a lot of noise too. But some of the regular noises that you're hearing
Yeah.
are coming from Blue Origin testing, a really great partnership where they have leased one of our historic test stands and refurbed it and using it to test multiple variations of their engines weekly, it appears. And so
Okay,
it's
so
been
people
great.
are going to lean forward for this next question. Why do they do it in the evening? That's always surprised me, but it seems like all of the tests I hear are in the evening. Is there a reason for that?
There are a couple of different reasons. One, just the schedule of what it takes to actually bring the crew in and on the day of test to kind of get everything in place and to execute that test safely and successfully. There's also some environmental factors in terms of the weather. On the days where it's cloudy, the tests are usually louder because the sound kind of bounces off the cloud ceiling and spreads further. It also produces an extra safety buffer. You have less people on site as well. Obviously, we don't plan to have any events, but we prepare for the worst in terms of our safety processes, and we always cordon off areas to make sure that if for some reason there was an unexplained anomaly, that we would be safe and keep everyone safe as well. So that's a couple of reasons why they typically test at night.
Okay, I want to go back to the moon landing a little bit. Mike Griffin, and this story has been related to me, so I'm not going to have the dates exactly right, but he talked about if we want to go to Mars or anywhere else, we need to have astronauts live on the moon for an extended period, a year, have them live there without getting any help, then have them live on on a spacecraft for a long time. Mm-hmm. And we've kind of done that on the space station, but the difference is the space station's right. It's right here. It doesn't take real long to get there. But when he said that, and it makes sense for something as far away as Mars is that part of part of the thinking of the ways that it might happen? I realize that these plans are made way out in advance and they change a lot as we learn things and develop new things. But is that even a remote possibility that we might build some sort of habitat on the moon and put astronauts there for an extended period? I won't say alone, but near alone, so we can find out what we need to do to go to a place like Mars.
The current architecture incorporates a number of aspects to help us learn the things that we need to do for that trip to Mars. The ultimate goal has always been to put humans on Mars. But as you said, there's things that we need to continue to learn how to do. And as you mentioned, we've had long duration stays on the International Space Station where we've been able to test the effects on our astronauts for being in space for long durations and also test the mitigation strategies for things that affect their physiological health that we know will be a problem on a long duration trip to Mars. There's also technologies of being on the surface of the moon that we need to develop and test to be able to support surface landings and operations on Mars. It also helps that the moon is only a 2 to 3 day flight home, as opposed to Mars, which is a 6 to 8 month flight home, depending on literally the alignment of the planets and your propulsion system you have. And so the idea that we can test things on the moon and learn and get smarter on various technologies that we didn't really have time to do during the Apollo program, because we were only there during Apollo program for 10, 20 hours or so. The current architecture has us eventually getting to 30 and 60-day missions on the surface where the crews are actually working, they're living, they're moving around, they're doing science experiments, they're doing different things to really help us test out the various systems that we need. The simple fact of how do we move hardware around on the surface of the moon, how do we offload cargo from a lander, how do we get it to where the crew needs to be and have the crew be able to work in their spacesuits to get that hardware where it needs to be and get things set up. All those are things that we really didn't get a long chance to work on during the Apollo program. And so doing those longer duration stays on the surface of the moon, again, right now we're planning for like 60-day missions, and we think that'll give us the information we need to be able to support what crews would do on the surface of Mars when we get to that point of the architecture.
Okay, the project's still underway at Marshall to 3D print using material on the moon to 3D print a habitat. That project's still happening, right?
Yes, it is. It is a really exciting partnership with industry partner called Icon.
Yeah.
We also have Drake State as one of our partners here locally, and some of the students where Icon is 3D printing homes out in Texas, and we have been working with their technology on how they 3D print, but actually using lunar regolith simulants and testing it in vacuum to understand how those different materials would react, how the actual hardware reacts and operates in those environments. Last year, we have a big vacuum chamber where we can test in different environments, and we had their hardware here at Center doing different test runs of how that would work on the lunar surface. And it really is a very novel technology, and our first application, we believe, that has the most benefit is how you would print landing pads, because the surface of the moon is not smooth. Yeah. And so a couple of our commercial companies through our commercial lunar payload services have experienced the challenge of having to land on an uneven surface. And so that is something that we're investigating how we can mitigate that by actually being able to 3D print a flat landing pad for future landers to come in and make it easier to land successfully on a flat surface. And so that's one application of that technology that we're looking at and hope to demonstrate, on future flights.
And if we could 3D print on the moon a habitat, a landing pad, whatever, that would translate to another world, to Mars or wherever.
Absolutely.
Correct?
Absolutely.
I mean, that's the goal, right?
It is the goal. And so it's really an exciting partnership and a lot of advancement in that technology. And I think it'll continue to advance as we continue to learn more and understand the different applications that we could use it for.
Okay, one of the things that gets mentioned periodically by people about Marshall Space Flight Center is that it is NASA's propulsion center. And so, pretty much know what kind of rockets we're going to use to go to Mars, whether it's using a NASA vehicle or using a commercial partner. But going to Mars requires it's hard to carry that much fuel with you. And I know there's a nuclear propulsion project at UAH working with NASA. So is that, when you see things like that, does that excite you? Because that's it's not just a want to, it's kind of a have to be able to go long distances.
It is, and our current chemical propulsion technologies, which are your traditional technologies that we've been working with for many, many years now, they are starting to reach the state of the art in terms of how much we have advanced. There are still advancements being made. I'll give you one example. We have a new project that we've been working on for a couple of years called our rotating detonation engine, RDRE. And that is a traditional chemical engine, but the structure of the actual nozzle and the thrust structure is different. And it is a much more efficient chemical engine. And so there are still advances we can make in chemical propulsion, but to support a long duration trip to Mars, you're really wanting to cut down the trip time to reduce the physiological effects on the crew, but also really make your missions faster and more efficient. You have a conjunction every 2 years, literally with the alignment of the planets where Mars and Earth are closest together, and that creates opportunities that you can get to Mars with less energy required, less propulsive force required. And we like to target those opportunities to make it easier. And there, it is possible with chemical systems, but it's a much longer trip to do. And so advanced propulsion systems like nuclear thermal propulsion, different hybrid systems that mix chemical and a nuclear electric or nuclear thermal are all opportunities that we can advance our understanding and be able to shorten those trip times to make that mission a lot more feasible. And so people have worked on nuclear thermal propulsion ideas since the 50s. There was a project called the NERVA project, which if you ever come on site, we actually have one of the test articles from that program is sitting in front of our propulsion development lab. And so it's been something that we felt like was going to be an advancement in propulsion for many, many years. and continue to work on technologies with industry and other government agencies and academia to really advance that, because we do believe it is one option that could really shorten that trip time and be a novel propulsion advancement for long duration, not only human space flight, but also for science missions and things like that.
This question may be out of left field, but you've seen the movie The Martian. In fact, there's a DVD kind of behind your head. But one thing about that spacecraft that they use, it seems illogical to me. There's a artificial gravity, with a wheel, like the old space stations that would go around like that. But it was a large spacecraft. I mean, is thought being put in now at places like Marshall about what kind of spacecraft do you need to have if we're going to go to Mars? It just seems like you got to have a place to move around. If you're going to be an SUV isn't going to work. You got to have something where people can move around and get away from each other a little bit to be in 9 months in space. So is that something y'all are thinking about?
Absolutely. Across the whole agency, not just at Marshall, but we're definitely part of it, as we have been looking and working with the industry to get their ideas as well on different concepts for what would be a Mars transit vehicle. Understanding the requirements that the crew would have in terms of the logistics of things that they need to take with them on that kind of trip. The different mechanisms that we would need to give them exercise equipment, for example, or sleeping quarters, and understanding how we would do science experiments. All these things are things that we've been able to test and learn on the International Space Station in low Earth orbit. We're able to take that information and feed it forward to what the crews will need for a transit vehicle to Mars, knowing that they're going to be in that vehicle for 6 to 8 months on a one-way trip to get to Mars, and then another 6 to 8 months to get home, depending on the propulsion technology you use. And so all the learning that we've been able to do at the International Space Station is now feeding forward for us talking about what does it look like to send crew to Mars, and how are we going to take care of the astronauts and make sure they can get there and get home safely. Communication delays from the distance we have is something that we have tested with the International Space Station, where we can introduce delays in our transmission of data and communications, and actually test. You guys are thinking systems. Ahead. So we are thinking ahead. And then how do we incorporate artificial intelligence and machine learning into these systems so that you take out the need to have a human in the loop for a lot of these systems? We are developing some technologies and some different experiments now where you can do predictive commanding. So based on the data coming off the system, it being smart enough to know which the next set of commands that need to be sent, instead of waiting on a human interaction from the ground and that's waiting 15 minutes to actually get the data, that it can already make the decision and implement the command that time. So those are some technologies things that we believe we're going to need to really make this Mars mission successful, that we've been thinking about for a number of years now.
Okay, so I would bet, I just said the technical issues always seem to me you guys are thinking ahead, like you said, and you're coming up with answers. Technically, it's feasible. I mean, we've already done enough stuff that 50 years ago was like, we can't do that, but we can. Mike Rudolphi, the late Mike Rudolphi, Rudy to his friends, who worked at Marshall for a long time, and he was consulting, and he told me that there are those who believe the hardest thing about going to Mars is not the rockets or the spacecraft or any of that stuff. It's whether human beings can do it. Is a lot of research being done into that? I mean, I know the space station extended stay, but once again, they know push comes to shove, you're not far away, but you're 9 months away. I mean, is that an ongoing thought process about what do we need to do to make sure humans can actually do this? Where talk about isolation, you'll never be more isolated than you would be 9 months away from the planet.
Absolutely. The agency has a program we call the Human Research Program, and it is based out of the Johnson Space Center, where our astronauts are housed. And a lot of the work that we've done on the International Space Station is really feeding forward to answer that question. We've had a number of crew members that have spent a year continuously on the space station. And as part of that activity, understanding how they cope with being away from their families for that long, understand the physiological effects on their bodies during a long duration stay in space. All that information is feeding forward to really address the challenge that Rudy was talking about, which is, how do we make sure that you can function and still, when you get to Mars, that you're actually still be able to do your mission, right? And then be able to get home safely. And it definitely can take a toll. If you think about being away from your family for a year, the men and women of our military do it all the time when they get deployed to forward bases and things and protecting our country. They have to do it as well. And so we have, I think that's why you see a lot of astronauts that are from the military, because they've had that experience of being away from home, being away from families to go accomplish a mission, and the mission focus that they have. But it's something that's taken very seriously. And the technology that we've advanced here on Earth, as well as what's being advanced in space, has really helped that. Early space station program days, I remember talking to the crews, and they had a satellite phone where they could call, and talk to their family. My wife works for NASA, and she got a call from an astronaut while at Target one day that she had worked with and made friends, and
That's
just called
cool.
to say hi. It was very cool. I realized my job was not near as cool because I'd never been called from the space station before. Now, because we've been able to increase the data transmission and bandwidths, the crews can FaceTime or video conference with their families as often as they have time to do. And so, just even in the time that we've been operating space station, the last 25 years, technology has advanced. It's made that long duration stay more bearable and for the crews. And I think we're going to continue to advance. Now we're testing how you use AR, VR technology for, like you and I, to have a conversation in this room, use an AR where the family has AR glasses on and the crew does, and it looks like they're sitting in the same room having a conversation.
Oh, wow. Yeah.
And so that's being piloted in a couple of experiments on the space station. So a lot of work being done to try to mitigate that concern so that those crews can be in a good place to go accomplish that mission and then get home safely.
Okay, one more Mars question. Knowing what we still have to learn, still have to do, still have to build, you're not speaking officially for anybody. When do you think it will even be feasible to make a trip like that? Are we 20 years out, farther than that? This is just your opinion. That you're not speaking for anybody other than just what you know.
I believe that we could launch, I would say, an uncrewed demo to Mars. We typically like to do a test flight of what we're doing. And I believe that we could launch and attempt an uncrewed demo by the end of this decade if we wanted to put the resources against that. And often these problems, while there are technological challenges we have to solve, they're all resource constrained. And
right? Wait a minute, by resource you mean money.
Exactly.
And that going to Mars would be by some factor more expensive than going to the moon. Am I correct?
Absolutely. And it is by a factor more challenging just in everything that has to come together. I believe we have an architecture that could easily put humans on Mars by the end of the 2030s.
Okay.
So I don't think we're 20 years away, but it will take focused resources to go do that, to develop the things that need to be done. And industry is making a lot of progress in a lot of different areas. And whatever we do, it's going to be through partnerships. It's going to be enabled through partnerships, and it's going to take a whole of nation approach to really accomplish something like it was in the 60s when we landed on the moon. And that, I think what you see in the administration's priorities is the steps towards moving in that direction to say, we're ready to go put humans on Mars. And you saw that in what was released in the president's budget request.
Okay. When you started as an engineer, you weren't in the slide rule days. You've been out there, but slide rules hanging behind your head. You didn't use slide rules. You were using computers. But engineering, doing the work that you did, it has changed in the way people go about it. My sense of it is, and not knowing exactly, but I bet there was a lot more paper then. And it hadn't been that long. How long when did you graduate from college?
25 years ago.
Okay, well that's not that long.
Right, right.
You're still a young guy, but has engineering changed as far as is the paper trail getting a little less every year?
Absolutely, it is, and the advent of different technologies, just computing power and what can be done on a phone now, what can be done on a desktop computer. Now we have supercomputers and quantum computers. The computing power has introduced new ways to do engineering where we can do so much more in modeling activities through analysis and through computing power that we couldn't do even 25 years ago. So I've seen a lot of change in that way in terms of moving into the digital age, reducing the amount of paper that's traded hands, because that obviously introduces opportunity for a mistake or a miss and that sort of thing. But just the way that engineering collaboration is done. And that's one of the things that NASA has been on the forefront. When you think about when we started designing and assembling the International Space Station in the 90s with even less technology, the integration work it took to ensure that piece parts coming from all over the world, the first time they actually get put together is in orbit, that they're going to actually mate together and work like they're supposed to. That is systems engineering, and that is where the systems engineering discipline really grew out of, is that need to integrate small systems into larger systems so they work effectively. And now, when I grew up, we did all that on paper. We mostly were doing that on paper. Probably, after 5 or 6 years of my career, they started to introduce digital approaches to system engineering that was really tied around databases and modeling. And now you're doing it through model-based system engineering, all digital models where you're doing it all in a CAD model, or you're doing it all in an analysis model, where there's very little paper that is being produced in that way. And so seeing that advancement has been really exciting, because it's changed the way our workforce is operating too. And so the students that are coming into the workforce now, that's how they've grown up. They've grown up with that computing power and that digital technology in a way that their mentors, the people that they're learning from on the job, haven't done. It's been an interesting dynamic to watch how the generations are learning from each other. The newer generation is learning, how to read a paper drawing, and the generation that's mentoring them is, okay, how do we incorporate this new digital technology into a way more efficiently of doing business? And it's been pretty fun to watch.
And maybe this is probably just me, but I remember the first time I remember seeing a digital representation of something was with SLS. That there was something out at Marshall where they had a big computer projection. Is SLS where things really started to change, or is that just me not knowing?
So we were doing some of the digital modeling back really on the International Space Station. I did some work very early on, very basic kind of digital modeling, really starting to incorporate it into our design processes on the Ares 1 vehicle as part of the Constellation program. We were doing some digital modeling of various components, especially in your structural analysis activities, but also in your design activities as well. And that was the first time where we were starting to incorporate the digital development through the manufacturing process. Typically, we would, even in the early days of my career, we would do digital modeling, digital CAD, but then we would produce a drawing and print out a paper drawing that got handed to the technician to actually go manufacture the piece of hardware. During Ares, we started to take that step even further, where the digital model was being transmitted as a digital delivery to the CAD machine or to the CNC machine directly to go print what was in the digital model. And that took out that paper drawing approach, to where somebody had to take a paper drawing and then turn it into the parameters that needed to be input into the machine that was going to manufacture the part. And so closing that loop, we actually started in the mid 2000s, late 2000s on the Aries program. And then that's come even further in SLS and how we're producing hardware as well. We still use paper drawings for some things, depending on what it is. But the move to the digital age, I think, is advanced rapidly.
So model-based systems engineering, is that kind of where it's where we want to be, where everybody needs to be these days? Because so everybody can see what's happening, and if one thing gets changed, you see how it affects other things. That just seems like if you're an engineer, you have to love that, don't you?
Yeah, I do, and there's so many benefits to it in the sense of at a basic level how we collaborate, and none of our systems are standing at a whole, and so we're trying to integrate with systems that are being built in other parts of the world by other companies or other agencies that have to come together, and so the ability to integrate those models and understand that I've made a change to a requirement or a change to how a system is going to operate. How does that affect all the other systems that touch it? That was really a part of my job coming up right out of school, was to be able to go trace all those things. And so it was a great way to learn about the system, because I had to know a little bit about all the systems enough to know when we made this change, how was it going to flow down and affect the other parts. Now all that's done for you in these digital models that you create from the start. In some cases, we've had to go back and rebuild the models because we may be using hardware that was developed before these models were created. If you think about SLS, we saved 4 sets of the shuttle main engines, the RS-25s, and those are the first four flights of SLS. We're using engines that were built well before the model-based systems engineering realm, and so having to go back and actually pull those models in of older hardware that's designed and integrated into it has been a part of the process.
So am I correct? You would have to basically make a model of the engine to incorporate with
That's
everything
right.
else.
That's
so
right.
You'd have to do the digital work on something you already had.
That's right, and there's a lot of technology on how to do that. One of the technologies we call white light scanning, where we actually can physically scan the part with some specialized camera equipment that will create that 3D model of those parts. One of the first big projects we did was a partnership with industry, where we took one of the old Saturn F1 engines, where they were not designed with digital modeling at all. They were all done by hand-drawn designs. We took that white light scanning technology and took the engine apart, scanned all the parts, and created the first digital model of an F1 engine, and then tried to reproduce the hardware with new modern manufacturing technologies like 3D printing or additive manufacturing, and then actually put them on the test stand. And it was a great project for our engineering teams to really understand and connect the dots between the way design was done in the 60s and then how design is done today. And what you really came out of that project was just a marvel for how the craftsmen of that day during Apollo, the amazing things that they built by hand, the things they designed by hand and the things they manufactured by hand, absolutely amazing. And on par with things that we can design today.
I was going to say, how did it work when you tested it?
It worked really well, but it was performed well. The parts performed as they should have, but it was a great project to really just respect and understand how great those designers and manufacturers and those technicians and those welders, those machinists were in the 60s to build intricate hardware that now we're using additive manufacturing from a digital model to print those parts. And we can print them more efficiently and faster with the same strength properties that we have. And so that's an example of how you can see how technology has moved in the engineering processes and some of the things that we do.
Okay. I want to ask a question about you. I mean, sitting here talking to you, it's obvious you know something about every single thing. Maybe not every single thing, but all the stuff I've asked you about that goes on at Marshall Space Flight Center. It also seems that your career set you up for this. But this is something that I'm not sure people know. how much you have to know for a center like Marshall Space Flight Center, considering all the things. I mean, there are astronomers working out at Marshall that have done some great things. But do you ever sit back and think, man, I can't believe I know all this stuff? I mean, that's maybe a stupid question, but I mean, one of the things that when they talk about Wernher von Braun is that he might not have could have done everything, but he knew what was going on and he knew how it worked, and there was a lot of things out there. So, do you see what I'm getting at? I mean, do you ever sit back and think, wow, I have to know a lot of stuff to do this job?
It's been very humbling, because usually it's, wow, I had no idea this was going on at the center.
Yeah.
And that has been one of the fun parts of the job, is that I do get to see a lot of activity at a surface level. As we move around and talk to our teams and hear from our teams and get briefed on different things that are going on across the center, it's always exciting to see and learn about things that are happening down in the labs that I don't know about, and discovering the technologies and the innovations that are coming from our teams that is happening at a low level. And it may be something that we don't incorporate for 4 or 5 years from now, but the seeds are being grown and germinated out of the hands-on work and the engineering teams that are being done. And so it's been exciting for me to even learn even more about what our center is doing, and all the places that our teams are contributing to what the agencies ask us to do for not only science missions, technology, and the human spaceflight missions, what we do. So typically when I sit back and think, it's, wow, there is a lot to do, but it also makes me very thankful for the team that I have. I have a tremendous team that I get to work with each day, both at the senior leadership level and then on down the chain. And with almost 7,000 employees, it's almost impossible to get to know each of those people individually. I wish I could, but getting we go around on a monthly basis. We take what I call field trips, and we'll take a field trip down to somewhere in the center just to go see what's going on in the lab. Just go talk to the workforce, hear from them. We try to keep it low key, and it's a great opportunity for us to really kind of dive in and find those places where there's things that are going on that we may not hear about on a regular basis that don't make the news cycle, but there's some great work going on by our teams that really are going to help feed the things that we're going to need for the future.
It's always seemed from outside it that Marshall was an exciting place to work and probably an exciting place to manage. I mean, yes, it's a job, and there are days when I'm sure it's not exciting, like trying to figure out how to put all the people who used to be in 2 buildings that are no longer there in offices, in the offices you have. But do you get that feeling that people who work at Marshall Space Flight Center, they like wearing those NASA T-shirts, and they like it?
Absolutely, we do. We have just a super engaged workforce, and people come to work every day to do their best, and they want to contribute. They want to contribute. They came to NASA to contribute. They were most likely drawn to NASA, like most of us, was because they were inspired. They were inspired by the Apollo program, the shuttle program, the space station program, through Hubble or James Webb or amazing science discoveries that we've made. And that inspiration is what said, I want to be a part of that. I want to be a part of that mission. And I get to go, one of the favorite things that I get to do now is be a part of swearing in our new employees. And so when we have a batch of new employees come in, I get to administer the oath to them to become part of the federal government and be a civil servant, to be a part of our mission. And just seeing the passion that these folks bring to what we do, but that extends outside the gate. And that's something that I think people outside of the Huntsville area probably don't understand. But we don't take for granted the tremendous community support and passion that this community has for what we do in space exploration. It's everywhere in this town and in North Alabama, and really across the state and the Tennessee Valley. The excitement that people have for our mission, that fuels us. That helps us even be more excited to get up and go into work and get to do some amazing things. And I get to brag on our community because I don't think any of my colleagues at other centers share, I will dare say they don't share as much excitement in their communities as we do, because a lot of them are in bigger cities that have a lot of other things that distract them. But this community really supports what we do. We have great partnerships with community leadership, and it is just it's an exciting time for us as we celebrate our 65th anniversary of Marshall this year being in this community. And we have a big community event on July 19th at the Orion Amphitheater to really celebrate the legacy and what this community has done for 65 years in supporting the nation's goals in space exploration, and then to start to look towards the future of how we're going to take that legacy and apply it to these new missions and new opportunities. And I believe that Marshall has the capabilities that we're going to need to do whatever mission that the nation wants to go accomplish, and we have the people that can go do that.
Yeah, and they live right here, well, around the area too.
Absolutely.
In the Rocket City.
Absolutely.
There's a reason why it's called the Rocket
That's
City
right.
too. All right, Mr. Pelfrey, Joseph Pelfrey, thank you. Thank you for being with us.
Thank you for having us. Thanks for helping tell our story.
Well, I love doing it. And thank you for being with us too. And remember, it works.